Alright, in this video we're going to continue working with solving radical equations, and we're going to look at a little bit more complicated problems that involve one or two more steps, but we should still be able to knock these ones out. So this will be solving radical equations, part 2. So remember, our goal when solving a radical equation is just to isolate the radical and then undo the operations that are going on around it. So let's take a look at this example. 5 times the square root of 2x minus 3 minus 3 equals 2. So in this problem, we have a lot of things going on with this radical. We want to get this radical by itself before we can do anything. So we have to undo what's going on the outside of the radical in order to get this radical square root notation isolated. So the first thing you want to do is look for any addition or subtraction on the outside of the radical, so not underneath it, that we can undo. So here I see I can undo by adding 3 to both sides of the equal sign. That's the inverse operation there. So 5 square root 2x minus 3 equals 5. Because the 3's cancel out, and 2 plus 3 is 5. Remember, when there's a number in front of a square root, that means you're multiplying. So here, to undo multiply, we divide. So the square root of 2x minus 3 equals 1. So I started off by undoing the subtraction, then I divided, and now I've got my radical isolated, so I can undo the radical by taking the square of both sides. So to undo the square root, you square both sides of your equation. So remember, the square and the square root cancel, so I've got 2x minus 3 equals 1. And now it's just a plain old equation that you should be used to solving. Undo again by adding 3 to both sides. 2x equals 4. And now divide by 2. X equals 2. So remember, with the square root and radical problems, you have to plug in your answer to make sure that it works. So we're going to check our answer over here on the side. And all that means is that I'm taking 2 and I'm plugging it in for x to see if it actually makes a true statement or not. So I've got 5 times square root of 2x minus 3 equals 2. You're going to plug in 2 for x. So all I've replaced is the 2 for the x. Then I do the operations. 2 times 2 is 4. 4 minus 3 is 1. Square root of 1 is 1. So this is 5 times 1. 5 times 1 is 5. And 5 minus 3 is indeed 2. So the solution checks out. So just a couple extra steps here, but it's still just solving. You're undoing until you get the radical by itself, and then you take the square on both sides, and then check your answer by plugging it back in. All right, another type of problem you're going to see is when you have two radicals that are equal to each other. So say I had the square root of 2x plus 22 equals the square root of 3x plus 31. So right now on both sides of the equation you have two radicals. And both of them are isolated because there's nothing going on the outside of the radical. You're not multiplying by anything in the front, and nothing is being added or subtracted after or outside of the radical. So if you're given an equation like this, you can right away start off by squaring both sides. Because now what happens is when you square both sides, the square cancels with the square root, and you get 2x plus 22 equals 3x plus 31. Because the square canceled the square root. And now I'm just solving an equation that you should be used to solving. I have to get my x's on one side and I have to get my constants on the other side. So I need to undo here. So I'm going to undo the x's first, and I'm going to subtract 2x on both sides. So if they're not on the same side, we can't combine them. We have to consolidate them and bring them to the other side of the equal sign. So then this 2x cancels with that 2x. I've got 22 equal 3x minus 2x is 1x, and then the 31 still stays there. Now I can subtract 31 on both sides. And I get negative 9 is equal to x. But now remember, we have to check our solutions to make sure that they work in the context of the problem. So 2x plus 22 equals the square root of 3x plus 31. You're going to plug in negative 9 into both sides of the equation for x. So 2 times negative 9 is negative 18. Negative 18 plus 22 is 4. 3 times negative 9 is negative 27. Negative 27 plus 31 is 4, and the square root of 4 is 2. So that winds up working on both sides. If it doesn't work, then there would be an extraneous solution. This would not be a solution to this equation. So when you have two radicals equal to each other, you just got to make sure that they're isolated, and then you can square both sides and then just solve like normal. All right, the last types of problems we're going to see are when you're dealing with radicals that aren't perfect squares or square roots. So our last example, this time we're going to look at the cube root of x minus 3 equal to negative 2. So the same rules apply that we did before, where you're just trying to isolate the radical. Once the radical is isolated, then you're going to do the undo, which in this case would be raising it to the third power. So the other problems we raised to the second power because they were square roots. Now we're going to do the third power because it's a third root. If it was the fourth root, you do to the fourth power and so on, because you're just trying to undo what's happening. So because this is isolated, there's nothing going on in front of or after it, I can raise both sides to the third power. And be careful, here's a mistake people will make. You got to put this in parentheses because your calculator will give you the wrong answer if you type in -2 to the third without parentheses. All right, so the cubed root of x minus 3 to the third, so these will cancel. And you're left with x minus 3 is equal to -8. Because -2 times -2 times -2 is -8. Add 3 to both sides. And x is equal to -5. Same rule applies where you should check your answer to make sure that it works. So I'm going to plug in -5 in for x. So the cube root of -5 minus 3 equals -2. Let's see if that's true. -5 minus 3 is -8. And the cube root of -8 is indeed -2. So we're good. This solution did check out for our problem. So these are some of the more complicated problems you'll see with solving equations. They just involve a little bit more steps or noticing when you have a different root that you have to raise both sides to clear. So you should be good to work on practice 7 now.